Assalamualaikum, good morning. Can you hear me clearly?
Assalamualaikum.
All right, thanks for the feedback. Okay, so there's an announcement to be made. So basically, this is our last lecture, meaning there's no more lessons, okay? But we will be meeting again for the final test, okay, which will be on the 14th week, meaning it will be on the 7th of July and at 10 a.m. Yeah, 10 a.m. 10 a.m. Okay, so this is the final test, 7th of July, 10 a.m. So make sure that you attend this test, yeah, because if you don't attend this test, if you resit, usually the test question is going to be much harder because you have more time, you have more time than the rest. So the receipt is usually much harder, yeah. So don't sabotage yourself. I mean, don't do a disservice to yourself. Come for the test, get it done, yeah. And then you can focus on your presentation. I think the group presentation is supposed to be during lab session, during lab session on the 14th week, but this also depends on your instructor. Okay, depends on your instructor. So perhaps your instructor will want to do it during exam week, the possibility, tapi just be prepared for this lah for the 14th week. Okay, right, so that is about the announcement. Okay, so now MapReduce is the last one, so meaning that MapReduce Hadoop will be in the final test lah. Okay, right? So let's start. Yeah, it's not going to take too long because this part is quite short. It's just an exposure to you, because we've seen that usually employers, they are, when they go through the resume for data scientists or data analysts, they are looking for things like this kind of big data benchmark like Hadoop, also MongoDB, things like this, because these are the de factos, and so therefore we have this session, this lecture, to expose you to this. Yeah, it's not a hands-on. There's no hands-on for this, but it's more of exposure to the concept. So the thing with concepts is that if you know the concept, you can use any software or any platform, any tool, and you still know what to do. Okay. So Hadoop basically is an ecosystem. Okay, why is it called an ecosystem? Because it is a very special kind of framework. Yeah, it's a very special kind of framework for big data, and it consists of different sub frameworks or families of frameworks, okay, inside it. So you can imagine Hadoop ecosystem to be having different components like this. Each have its own local goals, okay, local goals. And all of these local goals of these different components is working towards a global goal. Okay, a global goal. All right. So the global goal is your data science task, Nila. All right. So that's why it is considered as an ecosystem, and it is very efficient when it comes to big data. Okay, it's big data. So these are the components. Let's take a look at each and one of it. So the very first one, as usual, in data science, in data analytics, or in AI, one of the most important part would be the data. Okay, without data, the AI, the ML wouldn't know what to do. So in order for us to get data, we have to have special programs. So in Hadoop, there's a special program called SQL, which stands for SQL plus Hadoop. Okay, SQL Hadoop. All right. And this special program deals with structured data only. Okay, we've learned the different types of data, right? Structured data, unstructured, semi-structured. So for structured data from our DBMS, the component or the tool, all right, is Scoop. Okay, is Scoop. With Scoop, you can actually import data from the source tool into the HDFS, which is Hadoop Distributed File System, and you can also export it back into the RDBMS. So that's why we have the two-headed arrows. Okay. So HDFS is very, very powerful Hadoop distributed file system because it is the opposite of during my time where we have something like this, which is a centralized, okay, centralized architecture. Instead, Hadoop has distributed file system, multiple like this, okay, whereby it is easy for users to scale out and there's no wastage, all right? So this HDFS, okay, basically comes in several different sizes. Okay, small size, yeah, small size like 64 megabyte, 128 megabyte, yeah, small ones. So in other words, when you have small chunks like this, okay, you can add only the ones that you require. During my time, what we have is that we have this huge chunk. Okay, we may start off maybe a little bit smaller, lah, a bit smaller, okay, like this more, and then you know when there's growth it maxes out, it maxed out, so then we have to increase it, and then we wait, you know, we have to agak-agak lah based on historical data and experience how long it takes to grow out of this storage, yeah, this storage. So let's say 3 months. So we have to make sure that we have enough for it to grow, max out. So the problem with this kind of architecture is that, okay, is that we always have this part, which is the idle part. Not idle like K-pop idol, but idle, this thing. Okay, so we always have this idle part where it is not being used because we are waiting for it for the system to grow and then max out the whole thing. All right, so there's always idle. So sometimes if something happens, you know, these 3 months can be faster or it can be shorter. Yeah, shorter. So this is what we call as centralized architecture, okay? Whereas in contrast, if you have this distributed, you only extend what you need. So if you need 4, you max out everything. You use out everything. If you need another, you add. You need another, you add. So there's no wastage, yeah, and everything is very efficiently used and it is cost effective. Okay, you following so far, people? Okay, all right. So cost is everything. Cost is everything. Jangan you student mungkin rasa macam alah. So what's important about it? When you go into the industry, cost is number 1. Yeah. All right. So sometimes they do a trade-off between quality for the sake of cost. That's why sometimes bila kita tengok kan, there are new technologies, good technologies, but we have to wait until it is being marketed. Bila dia marketed, maksudnya dia dah considered the cost. The cost. So dia kena apa tu balance out lah cost, how much people will actually willing to pay for this brand equity, yeah, for the equity of this brand, and also is cost effective enough and make profit. Because even though satu technology is really good, but if it's not cost effective, it doesn't make profit, it will still not be marketed. Okay, so that is what you need to know as people who are in computing. Okay, so oh yes, the equivalent of Scoop is Flume. Okay, but Flume covers only unstructured and semi-structured data. Again, Flume is able to do both, which is import and export, hence the double-headed All right. Okay, next is MapReduce framework. So HDFS is where you store the data, yeah, and then you have MapReduce framework. So this is at the core of Hadoop because this is the one that is showing how wonderful, you know, the strength of Hadoop, yeah. So what is MapReduce? So it is basically a programming method. Therefore, it can be programmed using Java, C++, Python, etc. All right. The most important part for this is that you understand the concept. Okay, it's not a tool, it's not nothing, it's a concept. So you can get it wrong if you don't understand the concept clearly. And the kind of MapReduce framework is on, okay, it is utilizing distributed nature of the HDFS. So it's sort of like the same as when you do Java, object-oriented programming. You can actually use Java and still not code or not program based on OOP. It can still become structured in nature. Okay, but you know you are like having that idle part lah. Yang tadi tu banyak benda yang tak pakai. You beli handphone mahal-mahal, but then you cuma use it for calls. WhatsApp pun tidak, data plan pun tidak. Okay, so that's why you need to understand the concept. So you can, you know, so macam OOP, you will, you know, utilize dia punya object-orientedness and also dia punya, like for example, design patterns and all those things specific for OOP. Okay, so same with MapReduce, you need to understand the concept so that you can use any of these languages in order for you to come up with the MapReduce framework. Okay. So the thing with MapReduce framework, it can be applied to any type of data, structured or unstructured. Yeah. And the most simple, useful way to understand or the problem that MapReduce solves would be word count. Okay, so we'll have a look at word count. All right, so what you need to really understand is that not all problems can be solved using MapReduce. So it can only solve this embarrassingly parallel problem. So what in the world is this embarrassingly parallel problem? Well, it is a problem if and only if you are able to divide a single task into smaller tasks and then later recombine it into a single output. If you're not able to have any of these parts, then you should not use MapReduce because it is not an embarrassingly parallel problem. Okay, up to that point, faham ke people? Are you with me, people?
Boleh, Doktor.
Okay, all right. So, bila macam tu, you need to take a look at the component of map reduce. So, you have map function and you have reduce function. So, with map function, the job is to divide a big task into smaller tasks to be processed on different units of machine. So, when you have something like this, it means that your coding will have to make sure, all right, that it is standardized, you know, when it's launched, it is standardized. And also another thing is that when you divide your data, it should be in equal sizes. Okay, so that the same code can complete the process in, let's say, this standard similar time. For example, 3 seconds. Okay, and then here we have it in the form of key value pairs. Okay, remember again, balik semula, the NoSQL, which is in key value pairs, right? So when you're doing the word count, what we want is that the map function will do the counting, all right, after it has been divided. The job is to divide and do the counting, okay? All right, so let's take a look at reduce function. So reduce function has the job or responsibility of recombining the multiple small tests into a single result. Okay, into a single result. So it will have to be doing the reducing, which is, okay, combining it together. So an example would be, like this. All right, whereby the input is your data, yeah, and what you need to do is to be able to split it in equal sizes, yeah, as equal as possible. Of course, it's not going to be always the same because you may have odd number of words, for example, yeah, but you need to be able to, all right, divide it as equal as possible. So that is called splitting, yeah, when you have the key value pairs. And then after that, what you do is that you do the mapping, which is to do the counting of each unique words, just like your bag of words before this, yeah. And then after that, in order for you to get a final result, you do a shuffling. Okay, you do a shuffling where usually in word count situation, you will sort it in alphabetical order. And then you will take, the values, which is the 111, the count, the word count, for each unique word. Okay, which is the key. And then after that, reduce will do the calculation, the summation, the summation for each of the unique words, and finally produce the final result, one final result, okay, of all of the words along with its frequency. Okay, so we have a map reduce function. Okay.
Doktor,
Uh-huh.
kiranya dia macam tokenization
Dia bukan tokenization sebab dia basically kalau in word count ni, masa awal-awal tu dia akan divide equally. Once dah divide equally, kalau misalnya contoh dekat sini kan dia ada car macam ni. So of course kita akan ambil because kita ambil word, setiap word yang unique. Setiap word yang unique. Nak kata tokenization ni, kalau kita kata tokenization ni can have 2 gram, 3 gram based on grams dia kan? Betul? Hello? Kan? Jadi kalau you kata based on satu word, 1 gram contohnya. Maybe bolehlah kita kata something macam tu. Tapi dia tak panggil benda ni sangat macam, I'm not sure kalau dia panggil dia as tokenization. Because tokenization biasa daripada yang awal tu. Bolehlah kata kalau nak kata tokenization code. Kalau 1 gram lah, which is satu word. Okay ke? Faham ke?
Faham Doktor?
Okay. So ini word count. Tapi MapReduce ni can work with other sort of embarrassingly parallel problems. Okay. Alright, ada soalan lagi? Okay. Alright, so kalau tak ada, kita continue. Alright, so begitulah MapReduce. Okay, so make sure that you are dealing with an embarrassingly parallel problem. Alright, okay. Okay, next is HBase. Yeah, so HBase ni is a NoSQL database. Okay, now that sits or runs on top of HDFS. So you dah belajar benda ni, the different types of NoSQL. Yeah. Okay, and then, right, it was created for large table having billions of rows, millions of columns, because of big data, and it has fault tolerance, right, and able to perform horizontal scalability, and also masa HBase is specific to Google Big Table. So you dah belajar Big Table, jenis Big Table ni, okay? So when you say horizontal scalability, all right, it is like this. This is horizontal. Kalau vertical is like this, whereby dia macam zaman saya lah, it grows. Okay, satu unit but it grows like that. With horizontal scalability, you are adding more. It's sort of like macam you have small axias, yeah, you know, and you have processes yang standardized habis dalam semua dalam 3 saat. Whereas for this one, what we have is that contohnya dia ada, let's say 1, 2, 3, 4, 5, 6. Ada 6 jobs, yeah, being run. So it means that 6 kali 3 lah, which is 18 saat, because it is sequential. Usually here, we run it in sequential. Okay, it's like macam food panda lah. You have several different small food pandas to run, to go to different locations, and semua selesai dalam 3 saat, compared to you have satu, let's say Lamborghini ke ataupun apalah kereta besar-besar, but satu je, and it will have to do sequentially 6 different jobs, yeah, 6 different jobs, pergi to 6 different locations, where each finishes in 3 seconds, so the total would be 18 seconds. So slower by architecture. It is faster by architecture. It doesn't take a long time. Okay, and then, all right, Hadoop can perform only batch processing and data will be accessed only in a sequential manner for random access. So contoh dekat sini, yeah, is like, for example, okay, contoh kat sini kita ada several units of processing. Okay, and then you have several jobs. So the first one will always go in. Okay, and then the second jobs, okay, will have to queue up lah. Okay, all right, and the okay will queue up, and then the third job, for example, will also have to queue up. Okay, all right, so there's still idea queuing of this. So the thing here is that if the queuing goes too long, then it's time and indication to add new processing units. Okay, all right, so that's how it works. All right, and then okay, next is kita go to the next level, okay, or layer, which is the Hive, Peak Latin, and Mahout. This is where all of the magic happens, yeah. Okay, so here, the thing with Hadoop is that they promise that everybody can get on Hadoop punya ecosystem pretty literally quickly. Okay, very quick, because it is very very easy to understand, because it follows de factos, like for example SQL. So Hive is basically SQL-like. Okay, so it's good for SQL literate people. It deals with structured data stored in HDFS. So it is considered is known as HQL, which is Hive query language. Okay, and is able to run MapReduce program in a backend to process data in HDFS. All right. So for people who are comfortable with SQL, you can get, you can get to use Hive pretty easily. All right. The next one is Peak Latin. Okay, so it also deals with structured data. So Peak Latin is for people, right, that does do scripting, but they don't really like Java, Python, or SQL to process data. Because with SQL, okay, when you're trying to put in programming into it, you need to have this PL/SQL. Okay, you need to learn the PL/SQL. Okay, and with the Java, all right, sometimes the JDBC, and then also trying to you need to understand all of the different libraries, yeah. And then sometimes, it's like when you want to convert string to integer, it kind of leceh sikit lah. Macam tu kan for some people. So for those people who don't really like the stringent ways of Java and SQL, they can opt for PIC19, okay? To do the operations, to do the operations, transformations, okay, of their data. Okay. So I basically have never seen PIC19. I'm just not interested in it, yeah, because I can deal with SQL dengan Mahout ni lah, because Mahout ni Java based kan. Jadi, okay, so for people who are okay with Java, you can use Mahout because it is the library of all machine learning that's algorithms inside Hadoop, okay? So so adalah benda-benda all of those things, yeah, clustering, classification, everything. So the machine learning, Mahout is the machine learning tool of choice when the collection of data to be processed is very large, perhaps too large for a single machine. Okay, so yang bagusnya it maps over, okay, with the distributed nature, okay, of Hadoop. Right, next is Uzi. Okay, Uzi. Okay, Uzi. Any questions so far, everybody? And I see some reaction. Do you understand? 73 people. Okay. All right, Zami, thumbs up. Ideal, Nur Adika. Okay, hopefully the rest pun sama juga, yeah. Okay, now let's go to Uzi. Uzi basically is a workflow scheduler system. Okay, all right. So kenapa kita nak kena ada scheduler? Because we must understand that inside Hadoop, yeah, there's a lot of users. Okay, macam tadi lah yang ada queuing up. Okay, we have jobs queuing up. So we have possibly these jobs, and then we have these jobs over here. Okay, and we have like these jobs waiting. Okay, apa lagi warna? Over here. Okay, all right. So everything is queuing up, and Uzi is the one responsible to determine where each jobs is going to land in which unit processing. Okay, processing unit. All right, and with Uzi, it is a server-based workflow engine, all right, specialized in running workflow jobs with actions that run on Hadoop MapReduce and pick jobs, okay? It uses an old technology, okay, this is during my time, yeah, it's servlet ni, but this is showing that just because a technology is old, doesn't mean it is obsolete. It can actually be reused, and most of the technology now sits on top of old technologies. So that's why, don't wipe out every semester, wipe out the whole thing that you have learned. Stack it up, okay, add it to it, because like for me, the things like, on cloud, it is based from grid. Okay, grid technology. Okay, and grid technology is based on distributed technology, which is even more older. Yeah, so because knowing this, because understanding the concept can make me understand newer technology faster, instead of having to learn it from scratch. Of course, there's going to be new technologies, but the foundation like agents and all those things have been taught in universities. So if you wipe out every semester, dah belajar buang, eventually, you have to relearn everything all over again, which is a waste of time. Okay, so Okay, Uzi is also responsible for jobs that are related to one another, like for example, like this. Okay, whereby in order for job A to finish, okay, job A to finish, it requires data input. Once it's finished, its output, okay, will be fed into job B, and so on and so forth. All right. So job B cannot be triggered until job A finishes. So in this case, okay, in this case, for example, you have jobs. Okay, like that. So let's say inside here, there's already some jobs working inside the unit. And here, okay, you have your job A, job A. Okay, waiting. So, right, this job A may finish off first, all right, if let's say the blue job inside here finishes. Okay, so it goes in there. All right, so Uzi will be able to know that, oh, okay, one of these jobs is finishing, and once it's finished, if there's no queue behind it, it will actually trigger the second job, which is job B. Okay, all right, so it's going to go there. So that's how, and then so on and so forth. That's why on a grid, okay, what happened is that you're not going to have everything, ideally, you're going to have everything finished at the same time. But most of the time, there will be jobs that's going to be faster than another because of the queuing at the processing unit. Okay, so on and so forth, and then it will finish off. All right, and then recombine, for example. So in this situation, this is where you use something called DAG, directed acyclic graph. Okay, DAG, one to another. And Uzi is very good at, at determining this, at monitoring this until it finishes off. Okay. All right. So, any questions up to this point? All right. So then this is the last slide. Okay. So we have Zookeeper. It is a centralized service, all right, which maintain config information, naming, okay, synchronization, because we have distributed. So we have several servers on different machines. Yeah. So in case of any failure, all right, all of these things can be recovered, right? And all of the information, okay, should be correct and up to date, right? That's why we have all the disaster recovery, all of the cloud kat sini. Okay, cloud ni apa habis, for example, down, you always have another cloud to fall back to. Yeah, all of these things are important when it comes to the continuity of the business, and all of this must be spelled out in policies, okay, of the business, of the organization. Yeah, without this policy, habislah, susah. You know, there's nothing for you to work on. So that's why the policy must be intact. All of these things, okay, should be there. But if you're using a cloud, all of this policy is already, dah ada dah. You just simply have to pick and choose. Okay, so did I cover everything? Okay, so this one is going to be part of the test. Okay, so any questions before we end the class?
Madam. Madam,
Yes.
sebagai kepastian yang test untuk 7 Julai nanti tu fizikal lah.
Yang tu akan didetermine later. Mungkin fizikal ataupun dalam lab, saya kena bincang dulu dengan instructor you.
Okay. Alright. Thank you, Madam.
Okay. Any other questions?
Ni dia akan masuk sampai lesson 13 lah.
Dia akan masuk, yes, that's right. This is lesson 13. Okay. So make sure you datang masa test tu sebab kalau tidak you akan receipt tu memang biasa soalan yang susah-susah lah. So saya dah bagi tip awal untuk you boleh lulus dengan cemerlang, insyaAllah. Okay, alright. Anything else?
Doktor, ada
Ya.
contoh soalan ke?
Contoh soalan tak ada. Lagi soalan? Okay, so kalau dah tak ada kita berhenti dulu. Okay, so see you on the week 14 tu nanti. Okay. Assalamualaikum.
Waalaikumsalam.
Thank you.
Tiga tu.
Lah,
Thank you,
cikgu
Doctor.